Okay, we decided we're going to do nature of roots today. We haven't, that's a part of the algebra, a bit of the algebra that we haven't done.
Yeah.
Okay. All right. Have you looked at it before, recently? Or have you looked at it at all?
Yeah, because last week you told me that we'll start with that.
So you looked at it. Okay, let's just look at this page. I don't know how you broke up this different rules, but they've done it this way. This textbook, I've copied it out. Okay, you get delta, which is b squared minus 4ac. Okay, that's called the discriminant, or just delta. And that's a method or the way that you can actually calculate the type of, or the type of roots. Roots is just another word for x-axis or intercepts. So you get non-real roots, and that is when delta is smaller than 0. So you've looked at that.
Yeah.
And then you get real roots. Real roots means just roots that exist. They do exist. And that is when delta is larger or equal than 0. Then you can also real and unequal. So if delta is larger than 0, it will be unequal. And if delta is exactly equal to 0, the roots will be real and equal. And then you get real, unequal, and rational. Rational means that when your delta value is something like 16, in other words, it does have a square root, then it's called rational. And if your roots has got the value, let's say 18, 18 doesn't have a square root, then that can be real, unequal, and irrational. Do you know how to navigate this? Or do you have a different little sheet that you can work off? As long as you've got something like in your textbook in front of you, we can work from there.
Yeah, I have my textbook with me.
You don't have to have this flow diagram. I don't use the flow diagram. I just use a little piece of paper. Okay, I just want to show you what they try to do here. When roots are not real or non-real, it basically means there is no x-axis. So if you draw a graph, you'll find that these graphs doesn't intercept the x-axis at all. Because the roots doesn't exist. There are no x values. If the roots are equal, real and equal, it means that they exist, they touch the x-axis, but they only have one value. So if, for instance, if you have an equation like this, x minus 2, x plus 2 equals 0, it means that you have two x values. Oh, I've got a mistake there. Just make it. It means that you have two x values, but they are the same. They are 2 and 2. So that means you have equal roots. And obviously, if they're not equal, then they still intercept the x-axis, but they got different values, like x plus 3 and x minus 4 is 0. So your x-intercepts are -3 or 4. You still have x-intercepts. In other words, they are real, they exist, but they are not equal. Okay. And square and rational, irrational, I can't show you on a little drawing how it looks. So it's just plugging in that formula, and then they can make it slightly harder. And then we're going to do a spin-off of that. Right, let's do a couple examples. So if I give you 1, it's x squared minus 6x plus 9 is 0. And then I'm going to ask you, what is the nature of the roots? Okay, help me here, Amira. What are you going to do?
Why don't you first split your equation up to get your two x's?
No, we're just going to determine the discriminant. Because that will tell you what my nature of the roots are. Look, I'm not trying to solve x by completing the square or anything. I'm not solving anything. I want to know what the x-intercepts look like. In other words, I ask you, what is the nature of the roots? Are you with me?
Okay, yeah.
It's a different question. Look, they can also ask you to solve x. They can also ask you what's the minimum or maximum value. There's a lot of things they can ask you. They can also ask you to complete the square, etc. But if they ask you what is the nature of the roots, you need to determine b squared minus 4ac. Now, would you agree with me? B is -6.
Yeah.
Square minus 4 times 1, which is A, and 9, that is C. Now that is 36 minus 32. No, that is 36 minus 36. That's interesting. So that's exactly 0. Therefore, my roots are equal to 0. Is that, or delta, my discriminant is equal to 0. So now you can follow that piece of paper you've got, that sheet. If it's larger or equal than 0, it's called real. So it means exist. If delta is equal to 0, it is equal roots. But 0 also have a root, so it's rational. It's rational with an S or a T?
T, R-A-T-I-O-N.
Oh.
Yeah.
Okay, so what's the nature of the roots? It is real, it is equal, and it's rational. Look at that. Screenshot that or write it down. Look, we don't have a lot of work to do. It's just this part of the chapter. Then we're finished with all the algebra.
Okay. Okay, I took it down.
Pardon?
I took it down.
Okay, you took it down. Okay, what we're going to do, we're going to just do a couple of them. Just to get like a feel of what how to do it. So the next one is x squared minus 4x plus 3 equals 0. Nature of the roots. What is the nature of the roots? Delta equals b squared minus 4ac. Remember that you got that formula. X equals minus b plus minus the root of b squared minus 4ac over 2a. Remember that formula?
Yeah.
That underneath that root is just a discriminant. That's the nature of the roots.
You can use both, either or.
Well, you're not going to use both. You can just, for nature of the roots, you're only going to use this section because you don't need the rest.
Okay.
Okay, so now what? Minus 4 squared minus 4 times a times c. And that is 16 minus 12, so that is 4. Okay, so what is 4? 4 is a value larger or equal than 0, so the roots are real. 4 is not equal to 0, so it's unequal. So make sure they've got that in. I can't remember, they said unequal. Oh, they've got unequal in there. Unequal, and then 4 does have a root. So these are what? Rational. Rational. Okay, are you getting a grip? A grip on this? Okay, it's a pity b squared minus 4ac. Okay, number 4. Okay, you take this down.
I got it.
Okay, number 4. X squared. Why is this easy examples? We're going to make our own one. 2x squared minus 4x plus 11 is 0. Okay, so the discriminant is b squared minus 4ac, and that is negative 4 squared minus 4 times a times c. Put that in your calculator. I get negative 72.
Yeah, I'll say I think the 72.
Okay, so that is just when delta is smaller than 0. So this is non-real. It means it doesn't exist. There are no x-axis intercepts. Okay, so this was easy and kind of straightforward. We're going to slightly make it harder. So now for which value or values of k will the roots of that thing be real and equal? Real and equal. Real means larger equal than 0. And equal just means that. So real and equal is only that, where delta equals 0. Okay, I'm going to fix this equation. 6x squared plus 6 equals 4kx. I'm going to take it over to the left side. Then I have negative 4kx plus 6 is 0. So this is a quadratic equation where my a value is 6. You happy with that?
Yeah.
And my b value is negative 4k. Everything but the x. And my c value is just 6. Quickly look at that and tell me if you understand what I've done.
Yeah, I understand.
So now I'm going to work out delta. Delta is b squared minus 4ac. And that is negative 4k squared minus 4 times a times c. Therefore, delta is 16k squared. What's that? 6 times 6 times 4 minus 144. Okay, but for the roots to be equal, it must be equal to 0. Therefore, 16k squared minus 144 must be equal to 0. So 16k equals 144. Sorry, k squared. So I'm dividing 144 with 16. And then I get 9. Is that right? Yeah.
Yeah.
Okay. So what is k then? Therefore, k is plus minus the root of 9. So k is 3 or negative 3. You can also do this. Some students don't like that root. They'll take this root rather. They'll say k squared minus 9 is 0. So k minus 3, k plus 3 is 0. So k is 3 or negative 3. Quickly make notes of that.
Okay, I got it.
Nice. One more. Okay, this is going to be harder. So we have x plus h bracket x plus k equals 4d squared. Okay, show that the roots of that are real. So the roots must be real for all values of h, k, and d. Right, so I'm just going to do the following. I'm going to multiply that out. X squared, and then plus x times k is xk, plus h times x is xh, plus h times k, minus 4d squared is 0. Okay, just have a quick browse. You happy with that?
Yeah.
Okay, so now x squared, I'm going to factorize x out. Then I get k plus h. And then I have plus kh minus 4d squared is 0. So my a value is 1. My b value is k plus h. And my c value is kh minus 4d squared. Have a quick look at that.
Okay.
Okay, the c value is everything that doesn't have an x with, that doesn't have an x. And my b value is everything except the x to the power of 1. And my a value is everything in front or everything except the x squared.
Okay.
So now delta equals b squared minus 4ac. Right, it's k plus h squared minus 4 times a times kh minus 4d squared. Okay, I'm going to square that first thing. k squared plus 2kh plus h squared. And I'm going to multiply the 4 there. Negative 4kh plus 16d squared. Okay. Don't like this much. I have k squared plus 2kh minus 4kh is minus 2kh plus h squared and then plus 16d squared. This is a very difficult sum. Very difficult one. I'm going to factorize that first one. K minus h. K minus h. Then plus 16d squared. Then I have two brackets which are exactly the same. K minus h and then plus 16d squared. And that's where I'm going to stop. Why? I need to prove that it's always real. Those values always exist. And I've actually just proven it. Why? Look at this answer again. It doesn't matter what value I put into k or h's place. Doesn't matter. If I square it, it can either be a 0 or a positive value. It doesn't matter what value I put in d's place. If I square it, it will be a positive or a 0. And if I times it with 16, it will be 0 or a positive value. So it will always be what? Real. Because it will always be either 0 or a positive. So out of this, delta will always be larger or equal than 0. That is a difficult example.
That was a lot to process.
It is a lot to process. So what I want you to do, I want you to process it and then take your textbook and then page through that section on nature of roots and see if you can find some crooked sums like this. And then we do a couple of them, because if you're in a normal CAPS school won't give you something like this. You will not get it. But Impact has got a slight edge to it where they can actually ask you anything in the textbook. So strictly speaking, this is part of your syllabus. This is like on the higher end of the spectrum of your scope that your syllabus requires. But if you go to a normal school, you won't see this. They won't even show you this. But Impact doesn't follow those rules. So I want you to, after you've processed this, look at your textbook and see if you can find interesting sums there.
Should I send you a picture of it?
Yeah. Okay, let me just get my WhatsApp ready. So let's just make sure we can do those couple. Okay, let's see. Okay, yeah, you can see it's easy. Textbook, you can just look at the type of stars it has. Why am I not able to copy this now? So I've stuffed up something on my mouse. No, this is something wrong. Okay, I cannot copy this thing for some other reason. I cannot copy this, you sent me something that I can't copy. So, okay, which number are we going to use? I'll write it. Okay, let's do 1015.
Okay.
1015, I'm giving you M then x minus m, and then they have plus 2x squared equals 0. And they said, look, show that the roots of that are rational for all m values. If m equals 0, show that the roots are rational for all values of m. Let me just close this. There we go. I'm just opening up WhatsApp again to just see if I can copy it now. That's really interesting. Okay, let's just make sure that we know what's happening here. I've got mx minus m squared plus 2x squared is 0. So my first term is 2x squared, then plus mx is my b term, and then minus m squared is c. So a is 2, b is m, and c is negative m squared. Quickly have a look at that. See if you agree.
Yeah.
Download. Maybe if I download it, I can copy it. There we go. Copy. Okay, make sure, I'm just going to paste it here. Make sure that you understand or agree with me that A is 2, B is M, and C is minus M squared. Okay, so now let's do delta. Delta equals B squared minus 4AC. That is M squared minus 4 times 2 times C. Then I have M squared plus 8M squared. So this is 9M squared. So show that the roots are rational. If the roots are rational, then that thing will work under a root. So we can do the root of 9m squared. That is 3m. Therefore, the roots are rational. Bang. You see that?
So this is when it's except when m is equal to 0, right?
If m is equal to 0, then we have 9 times 0, which is 0, and 0 also have a root.
Okay.
Tell me when you're ready to continue.
We can continue.
Okay, let's look at that. I don't know why I couldn't copy now. So those are 3-star sums. Okay, 10.16 would be a problem. So they have m plus 1 x squared plus 4x plus 1 minus m is 0. Okay, let's just fiddle with this. So this is, I'm going to leave that as it is because actually I've got A there already. I have A, B, and C. This is easy. Okay, so A is m plus 1. B is everything but the x, which is 4. And C is 1 minus m. Have a quick look at that.
Okay.
It's kind of difficult sometimes. So, whoa. What's happening here? Okay, so I have delta equals b squared minus 4ac. That is 4 squared minus 4 times a times c. All right, I've got 16 and then minus 4. Okay, let's multiply that out. That becomes m minus m squared plus 1 minus m. So those cancel. So I've got 16 minus times a minus is a plus 4m squared. And then minus 4 plus 1 is times plus 1 is minus 4. So I have 4m squared plus 12. I have to prove what? Prove that they are real for all m equals real. Okay, I have a problem here. I don't have a problem. I don't have a problem. I can also factorize it if I want to. I can leave it like that. So now you have to prove that they are real. How will I know that they are real? Real means I'm getting a value of either 0 or larger than 0. So it doesn't matter what I put into m's value. If I square it, it becomes a positive or a 0. If I add 12, it stays a positive. So it's real. Irrational and unequal. Okay, let's do unequal first. Unequal means that I won't get a 0 value. Okay, it doesn't matter what I put in m's value. The lowest value I can get is 0. So if m is 0, then 0 squared is 0 times 4 is 0 plus 12, and that will never be equal to 0. So it will be unequal. It can never be equal to 0. I can never get a 0 value there. So unequal is correct. And then irrational means I don't have a root. I can't do the root of that. So that is irrational. So they allow you to leave it like that. You don't have to explain.
Okay.
We do those two left. And then you're going to tell me what we're finishing with. Because I think we might have completed the work for the term that you're going to write test on. We just have to double check that. That would be nice. I'm not sure. Okay, so we are doing on 10.17. X square plus x plus a square is 0. And discuss the nature of the roots. So they want to know what is nature. I don't know why my page is jumping the whole time. So I set something here. Okay. So what is the nature of the roots? Okay, that's kind of easy because a is given as 1, b is also 1, and c is a square. So the roots are b square minus 4ac. So delta equals 1 square minus 4 times 1 times c, which is a square. And that is 1 minus 4a square. Okay, now you're going to tell me what is the nature of the roots, if that is the discriminant. What do you think?
Want to be real?
This is a problem. I have a big problem here. If a is, let's assume a has got a value of 1. What would the nature of the roots be? It would be a negative value. Can you see that? Put any whole number in the place of a. I'll get a negative value.
Yeah.
But if I put 0 in a's place, I get 1 as an answer. That is a big problem. Because they told me at the end, a is element of R. So if a is larger than 0, then the roots will be non-real. So if I put a positive value in a's place, I square it, I get a positive value. Then I do 1 minus 4, and that's a negative value. But if a equals 0, then the roots are real and rational. Because if I put 0 in a's place, I get 1 as an answer. 1 has a root and it's positive or bigger. And then if a is smaller than 0, negative value like -2, then again, I get non-real roots. This is a dumb question. So they'll probably have something like this. Roots are non-real for a element of real, except where a equals 0. Roots are real and rational. Okay, I think there's a, to be honest, I think there's a mistake here. They should have said that AER should have been a larger than 0. That's my opinion. Okay, last one. Then we go through the syllabus and check if we've done everything. And then we start working on stuff that you're struggling with. Okay, so now they give this last sum, x minus k. Oh, there's one more thing we have to do after this. That equals b squared. You must prove that the roots are real for all values. Okay, I'm going to multiply that out. X squared minus rx minus kx plus rk minus b squared is 0. So the a value, let me just factorize that x out. Now look at this. Do not factorize the negative x out, because then you have a negative in front of it. Just a positive x. So then I have minus r minus k. That's kind of important. If you factorize a negative out, then you must multiply that negative back in to get the b value. And then it ends with what? Plus rk minus b squared. So that's my c value. A, B, C. Okay, let's write it here somewhere. A is 1. B is minus r minus k. C is rk minus b squared. So then delta is b squared minus 4ac. And that is minus r minus k squared minus 4 times a times rk minus b squared. That's a lot of something. So that's r squared minus 2rk plus k squared minus 4rk plus 4b squared. We have the same as that other sum. Same. R squared minus 6rk plus k squared plus 4b squared. This cannot be factorized. This is a kind of problem. This is a big problem. Oh, I've got a mistake. That's why it's a problem. That's not a negative. That's a positive. So this is negative 2. So there's r minus k plus. This is exactly the same as that other sum, Amira, that you said. This is a lot of processing. Okay, show that the roots are real. Okay, that's all you have to do. Why? It doesn't matter what values you put in. You're either going to get zeros or larger than 0 values. So it will be real. Just check this. This is exactly the same as the other sum. Different values, but exactly the same concept. And similar, this one is you seldom get something like this.
Okay.
Okay, I want to show you one more thing. And then we're going to stop the recording and just run through some of the syllabus stuff. They can also do this. This is kind of popular these days. So they should give you that and say, okay, for what value or values of x will p be, let's say, not real, 1, and 2, undefined. Not real means where delta is smaller than 0 now.
Mhm.
But delta is now that little section underneath the root, because b squared minus 4ac is underneath that root. So I can just say this is where x minus 3 is smaller than 0. So this is where x is smaller than 3. And undefined means I'm dividing with a 0. So that denominator must be 0. So x plus 2 must be 0. Therefore, x is negative 2. Just screenshot that. That is kind of very popular.
Okay, I took it down.
Okay. Right, I'm going to stop the recording because we